In this podcast, we're going to talk about what molarity is and how to calculate molarity. Molarity can be thought of as a measure of concentration. So this is not the best letter to use here, but A. Okay, molarity, we use a capital M. And to calculate molarity, it's going to be the moles of your solute, moles is your keyword there, over the liters of solution. So it's moles per liter. And for instance, if I had 6 moles of sodium hydroxide that I were to put into 2 liters, I know that the concentration of my sodium hydroxide in that solution is going to be a 3 molar solution. I use a capital M for that. Now, some things that you have to keep in mind for this is you may have to convert. So a lot of times you're not going to be given the substance in moles because moles is not something we can use in lab. You're going to be given grams. I have so many grams of solid sodium hydroxide I'm going to dissolve in so many milliliters of water. So keep in mind that these units are pretty standard. You have to convert milliliters to liters or grams to moles before you can calculate molarity. So this example asks us to calculate the molarity if 0.435 grams of potassium permanganate is dissolved into 250 milliliters of solution. So right away I'm seeing that I'm going to write out my equation. Molarity is moles over liter. I don't have either of those units in either of my givens. So the first thing I'm going to work on is to convert those to the units that I need in order to calculate molarity. So I'm going to set up a simple conversion. So 0.435 grams of potassium permanganate. And I'm going to actually use the molar mass to convert grams to moles. I know that in 1 mole of potassium permanganate, and I did this calculation ahead of time for you, there are 158.0 grams of potassium permanganate. So I'm able to get rid of grams and I wind up with moles. So I get, maintaining my sig figs, which is 3 sig figs, 2.75 times 10 to the negative 3 moles of potassium permanganate. Okay, so now I have that top value. On the other value, I'm given 250 with a decimal milliliters. I can either move the decimal 3 to the left to get it to liters, or I can use a conversion factor. I know that there are 1,000 milliliters in 1 liter. Okay, so this should be 0.250 liters. So now I'm ready to plug this into my equation. So I'm going to switch colors so you can see this clear. 2.75 times 10 to the negative 3 moles are put into 0.250 liters are going to give me the unit of molarity, which is moles per liter, so it's a capital M. And the answer that you should have gotten is 0.011, and I'm going to keep that 0 on the end so that I can maintain 3 sig figs because I have 3 sig figs in the 2 given amounts in my problem.